Rolling wheel. I am going to walk through the steps to create a rolling wheel attached to a path with rotation synchronized to its travel along the path. This synchronization will be achieved using an expression in Tahoma 2D. First, we'll be creating a wheel. Start with a new project. Create a vector layer. I like to name the column the same name as the layer that I'll be showing on that column. We can go ahead and extend it out to, oh, let's say 96. That's a number I typically use. I'm going to use a geometry tool, and I'm going to create the wheel at the center of the screen. For the purpose of what I'm doing here, I'll be animating the entire column, and so the only thing on this column is going to be the wheel. So I'll start by creating it at the center rather than have to move it there later, or an alternative would be to move the center point using the animate tool. So it's just easier if you can create what you're going to be animating at the center. And if you'll notice down at the bottom of the screen, if I hold down the Alt key, I'll be creating from the center. So I want to do that. First, I'll choose a circle here. Get as close as I can to the center. Hold the Alt key, click and drag, and I'll be creating a circle. Do a reasonable size with it. And then I'm just going to fill it in. This is going to be a simple circle. Then I'm going to pick a new color, go with something bright like red, and then I'm going to create a dot. And the reason I'm creating a dot on that wheel is so that when it's turning, I can see it. I can see evidence of it turning. Go back to full screen view, click this little icon here. So that's going to be our wheel. One thing I've been doing lately is changing the color of my scenes, getting away from just a stark white background, change it to something a little more like a gray. It's a little more aesthetic. Okay, do a save on that. Save early, save often. Next, create a straight line motion path. Now there are several ways to do this. I'm going to use the panel, motion path panel. Click the plus sign. The motion path has been created. You can see it starts at the center of the screen. I want to create a straight line motion path, so it starts out that way. I'll try to keep it that way. I want to use the point modifier, control point editor tool. Drag this out. I believe if I hold the shift key down, it's going to constrain to a straight line. No, that's not true. So I'm just going to be careful to keep it aligned to the pink line that I see there. And let's go ahead and now drag the other side out the same way. And just visually keep it aligned to that pink line so that it stays a relatively straight line. Okay. And you can see we've got a number of steps selected here. Now, the purpose of the motion path panel is if you're going to use this as a guide for your drawing. It's not a mechanical constraint on where you draw lines or anything, so it's optional whether to even show that or not. When the path is not selected, it won't show if you untick the eye. I'm going to leave it ticked for now. Now we're going to assign that wheel to the motion path. FX, and then we go into the stage schematic. You can see the path. It's not attached to anything currently. Drag the green node connection point up to the wheel. And that establishes the link. You'll notice the wheel has jumped to the beginning of the motion path. Now there's an option here. If we click this, it will synchronize the rotation of the object that we've attached to the motion path. We do not want that mode. We're going to be using an expression to rotate the wheel so it looks like it's in sync with the ground. If we were to lock it to the motion path itself by clicking and turning this into the diamond, that gives us an undesired result in our case. The wheel would not rotate the way we want it to. Now I'll add a new layer, and I'll draw a line to represent the ground. And I'll draw a straight line. Make it look visually where the ground would be. Okay. It's on a separate layer, separate column, so we can always adjust, fine-tune the position. Okay, now I'm going to measure the diameter of the wheel in order to calculate the circumference. I click on the measurement tool, click and drag to create the 2 points. $139.55. I'll round that off to 140. Now I'm also going to get the length of the path. $1,680. I'll round it off, a rounder number. So to calculate the circumference, I'm going to multiply the diameter by pi. Open up the calculator. 140 times 3.14159. That's pi to 5 decimal positions. 439.8, we'll round that off to 440. That's my circumference. I'm taking notes off to the side on a sheet of paper. Now I'm going to take the length of the path and divide it by 440 to get how many revolutions, how many rotations the wheel must do to go from one end of the path to the other. 3 point, and then it's a repeating number, 3.81. Well, I'll round that off to 3.82. 3.82 rotations to travel the full path. Now to put in the keys, I'm going to be also entering an expression. So we go over to the timing room, and on the wheel, there are two attributes that need keying. One is position along the path. So I start with that as 0 to be the beginning of the path. And what I'm going to do is have the wheel go out and come back in 96 frames. So at 48 frames, which is the halfway point, I'm going to have it be at 100% travel along the path. And then it's going to go back to 0 at frame 96. Do a quick test on that. So it goes all the way out, and comes all the way back in 96 frames. Now it wasn't rotating. We haven't done rotation yet. And this is where the expression is going to go. Click on the heading. Choose expression as the interpolation type. And the formula we're going to use is we're going to refer to the position along the path and multiply that by 3.6. There's 360 degrees of rotation in 100% of the path. If there's one full rotation for the full length of the path, that would be 360 degrees for 100% position along the path. So when you divide that 360 by the 100%, you get 3.6. So there's going to be a value of 3.6 for one rotation. When the value of position along the path is 100, that number times 3.6 is going to give you 360. So that's our formula that we're going to use as a starting point. Now, the formula that we're starting with is column 1, path or POS, either one is valid, they're both referring to the same thing, times 3.6. And you'll see the numbers fill in. We scroll down to 48, and we can see at 48 we have the desired result, 100% travel across the path, one full revolution. Now that's not our final yet. I just wanted to show you how we get started on that expression. We're going to take a look at the animation playing forward now. I'll let it loop. There's two things happening here. It's rotating the wrong direction. And of course it's rotating very slowly, so it's as if the ball is, as if the wheel is slipping along the path. Let's go back to the formula. Fixing one thing at a time. We can see that in order to rotate in the proper direction, we're going to have to reverse the number that we're putting in here. We're going to put a negative number in front of the a negative symbol in front of the 3.6. That's going to have it rotate in the clockwise direction as it moves from left to right. Take a look at that. Now it's rotating in the proper direction both ways. You see, as the number decreases, it's working for us. It's rotating in the clockwise direction going left to right, and the counterclockwise direction going from right to left. Now, what we need to do is have it rotate enough times so that it doesn't look like it's slipping. So back to our formula, and you'll notice I'm keeping to my best practice of putting my formulas in the column header so that it goes the full span of frames. I'm at this point in learning about expressions not trying to mess with partial segments, periods, or transitions, as they're called in the book, in the manual. I'm not trying to mess with partials. I'm doing the full range as one formula. Well, in order to keep our formula simple, we're going to let the formula do the math. This formula is more extensible this way. I've got my rotations here at this portion of the formula. 3.6, that's going to be a standard. You're basically going to change whether there's a plus, a minus sign in front of that or not, based on what your initial direction is. If your initial direction is left to right, you make that a negative 3.6. If you're going from right to left, you just make that a 3.6. So 3.82, that's our number of revolutions. I'm going to click apply on that. And then we see the numbers change in the column. And now I'm going to test it. So now it seems to be correct. Now, if you're having trouble seeing it at that speed, you could slow it down. Slow it down even further. Make it 8 frames per second. See that red dot? It seems to be synchronizing nicely with the ground. So we've achieved our goal in that respect. I do see that my path is slightly out of alignment with my ground image. It seems to be dipping below the ground. So I'm going to take a moment to fix that. Okay, to fix that motion path so that the wheel doesn't dip below the ground plane, I'm going over to the FX room. I click on the path. It's now active. Going to zoom in. I'm going to choose the control point editor tool. Click on the path. Get myself to frame 48 so that the wheel is over here. And I'm just going to be careful to bring that wheel up so it looks like it's back on the ground plane. Okay if it's a little flat on the bottom because maybe our wheel is a air-filled tire and it deforms a little bit where it touches the ground. Okay. That looks good for the one end of the path. Let's go back now. Carefully pan over. Yeah, the other end of the path, it's down a little further. You can balance those out if you care to. I mean, it depends on how close the wheel is going to be in your final camera shot. But I like where it is now. Go back to the 2D view. It's easier. We got a wider screen to view. Hit play. Keep it at 8 frames a second. And it seems to be doing what I wanted. That red dot is touching the ground where it should. It's not sliding. It's rolling along. I'll call that a success. Hopefully your results are working out for you as well.